Hello, today we'll be talking about complex numbers, and this is by me, Ananya Sindhi. So, first off, what are complex numbers? Well, complex numbers are combinations of real numbers and imaginary numbers. So, real numbers include integers, so basically just whole numbers, but from negative infinity through infinity, natural numbers 1 through infinity, whole numbers just 0 through infinity, rational numbers, so like fractions, repeating decimals, irrational numbers like pi because it never stops repeating, root 3 and root 2 because the numbers inside those square roots, so 3 and 2, they're not perfect squares, and whichever number that isn't a perfect square that is in a square root, those would be irrational numbers. So imaginary numbers are the square roots of negative numbers, and they're called imaginary because they can't be calculated as tangible values. For example, the square root of negative 16. So 4 squared is 16, and negative 4 squared is also 16. So there's no way the square root of negative 16 can be tangibly calculated into a value that is tangible. So examples would be root 2i, 4i, negative 3i cubed, I to the 29th power, etc., where I is a symbol for the square root of negative 1. Now, complex numbers are basically just a combination of the two, so it's written as a plus bi, where a is the real part and bi is the imaginary part. So now, examples would just be 2 plus 3i, negative 20 plus 75i over 5, negative 4i, etc. So now, adding and subtracting complex numbers. So if a is 4 plus 3i and b is 6 plus 2i, what is a plus b? Well, over here, first we could simplify the real numbers, so 4 plus 6, that's just 10. Next, we could simplify the imaginary parts, so 3i plus 2i, that gives us 5i, and then combine the two, so it would just be 10 plus 5i, and that would be our answer. So now, how about a minus bi? And keep in mind that since we're subtracting here, we would have to put parentheses around the 6 plus 2i because we have to distribute this negative to both numbers in the b term. So this would simplify to 4 plus 3i minus 6 minus 2i because we're basically just distributing that negative sign. And now simplifying the real numbers from this, so 4 plus 4 minus 6, that would just be negative 2. And now simplifying the imaginary numbers, so 3i minus 2i, that gives us I, and combining, so it's just negative 2 plus I. So now powers of I. Well, hopefully you notice a pattern here. Each row has I, negative 1, negative I, 1, etc. So after the fourth power of I, it just keeps repeating. Therefore, we only need to memorize the first 4 powers of I, and this is very useful for simplifying complex numbers that include exponents, and we will see those in the next slide. For example, how would you figure out I to the 73rd power? Well, one thing we could do is we could split that up into I to the 72nd power times I. Why? Because it'll make it so much easier to find factors of 72 than to find factors of 73 while simplifying. Well, this is just one way to do it. We could break that up into I to the 4th power to the 18th power times I. Because 4 times 18 is 72, and we're using one of these 4 numbers, or one of these 4 powers, so I to the 4th is 1 right here, so basically we can just sub in 1 into this, so it just be 1 to the 18th times I, and 1 to the 18th is basically just 1, and 1 times I is I. So yeah, I to the 73rd power is I. So now, how about I to the 52nd power? So first, we can just break this down into I to the 4th power to the 13th power, because 4 times 13 is 52. And we know that I to the 4th is 1, so 1 to the 13th power is just 1. So I to the 52nd power is just 1. What about I to the 27th power? So I to the 27th power is just I cubed, basically. Now this simplifies to I cubed, because over here this I cubed is I, and if we sub that in, so it just be I to the 3rd power, so I to the 3rd power is just I again. Now I to the 15th power, so you can just break this up into I to the 14th power times I, and from here we could do I squared to the 7th power times I, because 2 times 7 is 14, and over here we can see that I squared is -1. -1 to the 7th power is -1, and -1 times I is a -I. Now multiplying complex numbers. So evaluate root -4 times root -8. So for part the first step of this problem, part A, well, in order to simplify this, we need to first extract the negative parts of the square root. So it's root -4 times root -8. We'd have to extract the negative square root because it makes it easier to simplify. So just root -1 times root 4 times root -1 times root 8. And for B, since we know that I is the square root of -1, we can just sub in I. We can just replace the square root of -1 with I. So it would just be I times root 4 times I times root 8, and it would just be, so I times I, just I squared, and root 4 times root 8, we could just do root 4 times 8. And root 4 times root 8 is basically just 2 times root 8, because root 4 is just 2. So then that's just 2 times root 4 times 2. And again, since root 4 is 2, like the root 4 over here is 2, we can just put that out of the square root. So just 2 times 2 root 2, because again root 4 is 2. So just be 2 times 2 root 2, that's just 4 root 2, like what we can see right here. And again, I squared is just -1. And then for the last part, we just multiply -1 times 4 root 2, that's just -4 root 2. And that's your answer. So common error from the previous problem, please don't do this. So what some kids do is, from this problem, they would just take the square root of -4 times -8 directly, and then they would say that's the square root of 32, which is just 4 root 2. This is incorrect because we know we're working with imaginary numbers. So instead, like on the previous slide, we have to extract the -1, the square root of -1 from the -4 and -8 square roots, and then simplify that to I squared and times 4 root 2, which becomes -4 root 2. Now multiplying complex numbers, continued. So in a problem like this, so 2 plus 3i times 8 minus 7i, we'd have to FOIL this like a normal quadratic. So how do you FOIL this? So remember that it stands for first, outer, inner, last. So we take the first part, so 2 and 8, and multiply those. So 2 times 8 is 16. Next, we take the outer numbers, so 2 and negative 7i. 2 times negative 7i is negative 14i. We take the inner terms, so 3i and 8. 3i times 8 is 24i. And finally, we would take the last term, so 3i and negative 7i. Well, 3i and times negative 7i is just negative 21i squared. And now we have to add those all up. Remember that I squared is negative 1 from the previous slide, so 16 plus 10i minus 21 times the negative 1. That just gives us 37 plus 10i. Now, dividing complex numbers. And remember, when dividing them, you have to multiply the top and the bottom by the complex conjugate of the denominator. And we do this because we want to get rid of the square root in the denominator. In math, we just never want to see square roots or any kind of roots in the denominator. And remember that I is the square root of negative 1, so we don't want this as well. So for example, for this problem, 2 plus 3i over 1 minus 5i, we'd have to multiply this by the complex conjugate. So the conjugate is basically, if it's 1 minus 5i, then the conjugate would be 1 plus 5i. If this was 1 plus 5i, it would just be 1 minus 5i. So yeah. Now from here, we'd multiply the top to the top and the bottom to the bottom. So by foiling, we'd first multiply the first term, so 2 times 1 is 2. Then we'd multiply the outer term, so 2 times 5i is 10i. Next, we'd multiply the inner term, so 3i times 1 is 3i. And the last term, so 3i times 5i is 15i squared. Over, and now we'd have to multiply the bottom terms, so 1 times 1 is 1. 1 times 5i is 5i. Negative 5i times 1 is negative 5i. And negative 5i times 5i is negative 25i squared. That can be simplified to 2 plus 13i plus 15 times negative 1 over 1 minus 25 times negative 1, because again, I squared is negative 1. And now that becomes 2 plus 13i minus 15 over 1 plus 25, which becomes negative 13 plus 13i over 26. And that's just basically, so simplifying that, we'd just get negative 1 plus I over 2, because 13 over 26 is basically 1/2. Simplified. And breaking this down, we'd get negative 1/2 plus 1/2 I. Now, next problem, so 14 over I. Well, the complex conjugate is negative I, since the number is positive I, and if the number was positive I, the conjugate would be negative I. So over here, 14 over I times negative I over negative I. And again, we're just multiplying by the conjugate because we're trying to get rid of the square root from the bottom. Yeah, so then multiplying that, we get negative 14i over negative I squared. I squared is negative 1, so we just replace the I squared with negative 1, so it would just be negative 14i over negative 1, so that just be positive 1. So just be negative 14i over 1, and that would just be negative 14i. Thank you for your time, and I hope you have a nice day.